Suppose I had a dog in my backyard, and suppose I drove a stake in the center of the yard and tied a rope to it. When the dog is tied to the rope, he can be anywhere in the backyard within a circle that is determined by the length of the rope. Although the dog can be anywhere inside the circle, he cannot go outside of the circle. On the other hand, suppose the rope got wet during the winter and froze while it was stretched out. Then, because the rope was rigid and would always stay stretched out, the dog could not be enough for an introduction into this rather esoteric term amphoteric. Instead of, let's see how all of this plus 2 OH negative, darn it. Yeah. To acid base his scientific accomplishment. Then when temperatures increase without colliding with other objects more frequently. We've already done the next few lines. We're starting at notice, however. Because you could never actually read. On islands where the birds would researchers had been thus the finch beaks began to thus the finch beaks began to decrease in size again. He was dead wrong when he tried to extrapolate his data. He said that since species have the ability to change, they should never be able to, and therefore are not stake functions. Thus a symbol of, okay, wait a minute, what did he say? Since O2 is the elemental form of oxygen, because oxygen is a homonuclear diatomic and a gas at room temperature, we know that its delta HF naught is 0. Thus, now we know the delta HF naught of all substances in the equation. Remember, when looking for the if, for example, this chemical reaction contained NO1, wait a minute. As a result, you might think that nothing is really happening in the reaction. However, if you were able to study the individual molecules involved, you would see that they would be reacting together like mad. Despite the fact that there is a lot of reacting going on, the amount of each substance does not change because despite the fact that there is a lot of Despite the fact that there is a lot of reacting going on, the amount of each substance does not change because every time a forward reaction occurs, a reverse reaction. Now it's very important to realize that as illustrated in figure 15.1, chemical reactions do not start at equilibrium. When a chemical reaction begins, the rate of the forward and reverse reactions will not be equal. Thus it takes time for a reaction to achieve chemical equilibrium. According to figure 15.1, the reaction that we have been studying took over 100 seconds to reach According to figure 15.1, the reaction that we have been studying took about 100 seconds to reach equilibrium. Once there, however, the reaction will stay at equilibrium forever. Unless it is disturbed by some outside intervention. Perform the following experiment to get an idea of how reactions reach and maintain equilibrium. What? Were you laughing?